This is our first example where we're looking at a question that involves a slope. So you're going to have to be a little bit careful when you draw your diagram to realise what is going on. So a body of mass 10 kilograms slides down a smooth plane. Now we know that it's a smooth plane, so we know this question's not going to involve friction. I'm going to draw the diagram so you can see what I'm doing and why. So the first thing is I've drawn in a slope. And on that slope, I'm going to put in my body, and my body I've put in as a point. It has mass 10 kilograms. We know that weight operates directly downwards. So we have weight equals mass times gravity. We're told the mass is 10, so I've got 10g that is operating downwards. The normal reaction operates perpendicular to the surface. Now, all the questions we've done until this point, we've had a horizontal surface. This time we have a surface that is a slope. So it is perpendicular to the surface of the slope. Now, let's see what else we have. A body of mass 10 kilograms slides down, so we know its motion is going downwards. Acceleration is in the direction of motion. Now, acceleration is a vector quantity. So when we're going to do our axes for our unit vectors, what we do is we have I, which is parallel to the slope, and J is perpendicular to the slope. Find the acceleration of the body and the reaction between the body and the plane. So what are we going to do? What we need to do is consider the 10g. We're looking at our normal reaction being perpendicular to the slope, and we're looking at our acceleration being parallel to the slope. So because our weight is going directly down, we have to resolve it into its components. Now, we are told the slope is at an angle of 60 degrees. So if I'm going to take my 10g operating downwards, what I'm going to do is draw a new triangle. So the 10g is going straight down. What I can do is consider this as a right angle triangle. Here is my right angle. Now, if 60 degrees is here, 60 degrees is there. So how do I work out the length of the sides? I'll just move the 10g. There's the 10g, there's the hypotenuse. What I have is a right angle triangle, and I can use the same relationship as I've used before. Considering the opposite side involves sine. The opposite side will be 10g sine 60 degrees. The adjacent side then will be 10g cos 60 degrees. What I've got is n operating directly upwards. So down from that, I will have that 10g cos 60 degrees. With the 10g sine 60 degrees though, I don't write it so they're joined up as in my triangle diagram, but I write it coming off the object. So I now have 10g sine 60 degrees. Next part is to now look at the R equals MA part. So if I was looking at the forces that are involved, again I will colour code. The only thing operating in the I direction when I resolved my weight force is the 10G sine 60 degrees. My motion going down the slide, so my acceleration was 10 mass times AI. Next thing I can consider is the parts that are perpendicular to the plane. Again, I will colour code. We have the N going directly upwards and the 10G cos 60 degrees directly downwards. Both are perpendicular to the plane. So I've got N minus 10G 60 degrees. That is the J component. So what I know is 10G sine 60 is equal to the 10A because it's operating in the I direction, and N minus 10G cos 60 degrees is equal to the J direction, and there is no motion in that direction. 10G times sine of 60 is root 3 on 2, so equals 10 times A. G we know is 9.8, so I get A equals root 3 on 2. G I could multiply through by 9.8, but I've left it as it is there. Next thing I know is N minus 10G cos 60 degrees equals 0. Well, we know cosine of 60 degrees is a half. 10 times a half is 5, so I've got N minus 5G equals 0. So N equals 5G newtons.